Good day. We are starting to look at how we convert between things like mass, moles, and particles. But before we get to that in detail, we have to understand the concept of molar mass. You should have a piece of paper that has two of the slides. This is a 4-slide PowerPoint, and that means the last 2 slides you will have to copy because we'll do a couple of examples for how to figure out molar mass. You'll need your periodic table handy, and it should be fairly straightforward. So, molar mass is the mass of 6.02 times 10 to the 23rd particles. That means it's the mass of a mole of particles, and the periodic table is constructed that way. If you had a mole of helium atoms, it would weigh 4.00 grams. So when you look at those things, molar mass in the periodic table, they may say they're in atomic mass units, but we can think of them as being in grams per mole. Now, here's a magic moment. The G, that's the abbreviation for grams, and look at the amazing abbreviation for moles. You no longer have to write the E at the end of it. MOL, lowercase. So molar masses will always have the units grams per mole. And as I've said, the periodic table gives you the molar mass for each element. For compounds, we use that information to calculate the molar mass. So we have to look at the number of atoms of each element in a compound, and we're going to take that number, which is usually a subscript, we're going to multiply it by its molar mass. We do that for each element, and then we just add them together. So that's the mumbo jumbo. Now it's time for some examples. And this will be a bit of overkill, because for the notes, we really want to show you clearly how to do it. And eventually, you will start to abbreviate and short circuit how you get to this. So let's start with something very important, wawa. Well, we can see in water, 2 hydrogens, 1 oxygen. So we're going to indicate that. And then we're going to look up the molar masses of those beasties. And we're going to multiply them together. So we install a few headings here. The number of atoms comes from the subscripts in the formula. The molar mass comes from the periodic table, and we're multiplying these to the right to get a total. So we have 2 atoms of hydrogen. Periodic table says 1.01 grams per mole, so we get 2.02 grams per mole. Oxygen, 16.00 grams per mole. It's in a compound here. And now we have 16.00 grams. So the compound's mass comes from the total here, if we had a mole of these. So that is the molar mass of water. And when we get into hydrates and things, this is a handy number to remember. So water will have a molar mass of 18.02 grams per mole. We'll do the same thing for lead 2 sulfate. Same headings. Now we see we have 3 elements, and it's a 1, and a 4. So we do lead first. Lead atoms are very massive, especially compared to something like hydrogen. Sulfur, not quite as massive. And now we have 4 oxygens. By now you know it's 16. 16 times 4 is 64. And you can see when we do these things, our molar masses usually go to the nearest 100th. We get those. Now you might be saying, hey, those things have 1/6 vig, and the answer, that would be incorrect. There's no uncertainty. We know for sure lead is 1, sulfur is 1, and the oxygen is 4. So these are not measured values when we get them from a formula. These molar masses are measured values. So we've multiplied across the right, multiplied, got it to the right, multiplied, got it to the right. And now we just add those together. And we're adding, so we maintain our place value. So we get 303.25 grams per mole. So molar masses have to be automatic for you. So make sure you get good at this. You'll need them for the next section.